So there's two different things going on here. One is about unprovable truths that Gödel showed, and the other is about this tendency, not lawfulness of 2 + 2 = 4. I want to say very different things about those two things. So as far as Gödel goes, I just want to clarify one thing. Gödel did not come up with a sentence and go, this is true, but we can't prove it. Rather, what he showed was that provability is always relative to an axiom system, to a formal system. I can give you the 7 axioms of piano arithmetic and go, this is our system, piano arithmetic, these 7 axioms. Now, what can we prove in this? And what Gödel did was he found a sentence that's not provable in piano arithmetic. One consequence of Gödel is that from piano arithmetic, there's a sentence that you can't prove in piano arithmetic, but we know it's true. And basically the sentence says, it's self-referential and it says, I'm not provable in piano arithmetic. That sentence is not provable in piano arithmetic, but it's true. What Gödel proved is that for any axiom system, you can always find a sentence that's not provable in that system. And the sentence always says, I'm not provable in the system in question. But the sentence for piano arithmetic, the sentence that Gödel found, let's call it G, is provable in another system. You can go to a different axiom system that proves G, but that system will have other sentences that it can't prove. So what Gödel showed is that any axiomatic system in mathematics that's strong enough to even give us basic arithmetic will always have unprovable truth. The way to think of it is, for any axiom system you lock in on, there will always be unprovable truth. Okay, that's what Gödel proved. Now, this business about 2 + 2 = 4 being a tendency and not a law, here's what I want to say to this. That sounds wrong to me. I suspect that if I went and read this book, I would go, oh, that's what he means by it. There are things I can think that somebody might mean by that makes me go, oh, okay, that's right. But like the straightaway way of understanding it, 2 + 2 = 4, the sentence in English that says what we think it means, 2 + 2 = 4, is just true. And it's necessarily true. And it's proven from standard arithmetic. What he might mean is like, oh, it's possible to construct a different theory where 2 + 2 = 4 comes out not true. In which case I want to go, yeah, that's definitely true. We can do that. But in that system, I think the sentence 2 + 2 = 4 wouldn't mean what we mean by it. The thing we mean when we say 2 + 2 = 4 is just true. So I'm not sure what he means when he says that, but the way I would flat-footedly interpret the sentence 2 + 2 = 4 isn't a law, it's a tendency, my reaction would be like, oh, that's wrong.